Hey, it's another Saturday night data party. It is Saturday, the 18th of April. Today, looking at some SEO data. So one of the things that I'm curious about is if we can glean from data like the stuff you get out of a service like RFs, can we get a sense of what causes an article to rank? Specifically, I want to look into marketing technology. We're going to look at this year's data. Hey, Perry, how you doing? So we're going to look at only live data in the English language. And we care about traffic. We like traffic. Let's see. I'm going to turn on just my stream viewer here so I can see what I'm doing. Good. So the question to ask is, can we infer anything? Whoops, I don't want Spanish, I want English. Can we infer anything about what's likely to get an article to do well on the topic of marketing technology? So to do this, I'm going to need a bunch of data. So let's get started. All right, and for this, do we want to use the database for this? Yes, let's use the database for this. And instead of loading files, let's do, let's call it RF's data frame. And actually, we want to write the query first. We're going to do a select. What are the fields in our database that we care about? Actually, you know, let's do it from the data file first. I think that's actually a good starting place. So let's go. Oop, did I specify? I need to specify its content URLs. And we'll call this SEO. All right, so we have an initial look at 38,000 variables. Let's do some cleaning. We want to make sure we get all the data in the correct types. And make it distinct. Let's see what's in here. We get hi, Christine. Nice to see you. We got article titles. We got the URL of the title. Got authors, domain ratings, referring domains, traffic, the value of the traffic in dollar amounts, Twitter, Facebook, and Pinterest shares, date, number of words in the article, HTTP code, and a republished date. All right, let's get rid of, let's do a little bit of cleaning here. We don't need HTTP code because all these should be working. If they're not working, there's really no point in looking at this. We can get rid of that for sure. Let's also fix that date field because those are both POSIX dates, and you know, it's fine. Let's leave them. We need to get rid of the number field. That's just the number of rows. That's pointless. It's not going to be helpful. And what else do we want to, anything else we want to get rid of here? The rest of that stuff looks pretty good. Okay, so let's do a little bit of cleanup here. You'll notice we've knocked out a few of the fields there. Now, some things that we might want to consider when you're looking at a URL, and when you're looking at content titles, what are the things that are worth paying attention to here? Something like the domain might be a really helpful thing to see, like, do certain domains just rank better and therefore get better traffic? So we're going to add in the URL tools library. And let's call this root domain equals domain of the URL. Oh, help if I actually loaded the library. All right. content URL. Helps if I get the field name correct. So now we see root domain, we've got internet.com, smartinsights.com, stuff like that. Let's look at this a little more closely. So you can see that we're now starting to break these down into individual domains to see if the domain is going to be relevant. And then let's also add in, what else do we want to do? Well, you know, let's see if we can figure out a couple of useful keywords that we might want to tag in here. To do this, we're going to want to do what are called collocations. So we're going to go back up to the top here. We're going to add in the quantata library for text mining. And let's see. For this, we want to turn and do some cleaning. So let's go to how do I want to do this? I want to understand what's in the headlines first before we do anything else. So let's do let's turn this into something called TextDF, but I only want the article titles. Content title. And then let's do a bit of cleaning. We should get rid of stop words because stop words are bad. All right, so let's go through. Oh, didn't load quantata. That's stupid. All right, what did I screw up? Duh. Content as content title. Would help if I had a stopwords file handy, wouldn't it? Where's my stopwords file? Much better. All right. Let's look at our collocations now. So what we're doing, a collocation is when words appear next to each other. So in this example, marketing technology, the category, you're going to see marketing and technology appear next to each other a lot. And one of the ways to digest a piece of text very quickly is to identify the collocations and determine, and then what we're going to do is start counting them. So let's do this. Let's do if run colloc equals true, because we won't want to run this every time. This can consume a lot of time. Did I break something? I think I did. Yes, terminate it. Oh, I definitely blew something up. There we go. All right. Let's go back into our project, which literally just exploded. And start over. This is why we copy and paste things. All right, so we should also specify run colloc. In this case, today, right now, we want it to be true. Let's just double check our code. Transmute it, and then go through and tokenize it. And then go. So go. Oh, I see what I did wrong. At no point have I made this. Actually, that's not true. Just the set should be distinct. Let's double check. I didn't make it distinct on the second pass through after I removed HTTP code and row number. Well, that'll teach me. Blow that up, start over. This, by the way, is what data science looks like most of the time behind the scenes. You never see the complete and total abysmal failures of things just blowing up constantly. So let's see. Here's where the error is. You can see up until this point, we've got 36,000 rows. Let's make it distinct. This is going to shrink that data frame down really small. If you look in the clean data set, it's only 7,000 rows. And anytime we're running a really big text mining operation, the smaller you can make your data set, the happier you're going to be and the less time it's going to take. Look at that. Just by shrinking that down and removing duplicate titles, we're done in seconds. Okay, so let's look at the text stat. So the co-location, I got some press releases, that's not helpful. Digital marketing, marketing trends, marketing technology, SEO news, marketing services, customer experience. All right, so we've got a few things here that are kind of useful, right? There's some diagrams that might be useful. So let's do this. Let's go now back into our table here. And with this information that we have, let's do digital marketing as a keyword, marketing trends, marketing technology. Digital marketing count equals string count. And we're going to do this on content title. The pattern is digital marketing. And what this is doing is going to create counters for the number of times specific keywords occur within the title. There is a way to do this programmatically, but as you can see, it takes some doing to do that. If you just ran it, you're going to get a lot of garbage the first couple of times through. So I find that it's helpful to do it manually, at least for investigations like this. I don't know why you keep showing that, but okay. Marketing technology, SEO in general, SEO customer experience. SEO. And we'll make this lowercase as well in case that is happening there. Actually, do we want to do all of these to be case insensitive? If so, I think we do. So for that, we're going to need to transform this. We're going to do it as a regex on this term, and then ignore case equals true, and then add that. Oops. So we're going to want to do this for all of these. Because these are titles, which means we don't need the second version of that. Okay, let's do what else is in our diagrams? SEO, B2B, and customer experience, I think would be good ones to do. Okay, that's a good blend to start. And what we're going to see is we'll now see in our frame here, we've got our title, got a URL, author, domain rating, referring domains, traffic, traffic value, Twitter, Facebook, Pinterest. And then we can have our counts of topics. You can see there's a few in there, not many. So next what we want to do is, from the things that are numeric alone, is there enough data to warrant further investigation? So let's do this. Let's load our core plot library. And for this, let's do a Spearman. We should get the numeric data fields out first. So from here, this will create a data frame of only fields that have numbers in them, because you can't do correlations on things that aren't numbers. It just doesn't work. And now anything that is an NA, we want to turn to a 0 in this particular case. And now, do we think we have any fields that are 0 value fields? If so, let's get rid of them. Because again, you can't do a correlation on fields that are just straight zeros. It just doesn't work. Okay. What have we got? Clean fields. Well, if we had a whole bunch of fields with zeros on it, that's not good. And now, let's see what this looks like. Helps if I load the whole thing. So what do we got? Referring domains, domain. Well, that wasn't helpful. All right, let's kill off the caret stuff, because that clearly did not in any way do what I wanted to do. And run it this way. 14 variables. Yeah, blew that up. All right. X must be numeric. Oh, duh. Let's see what we got. So our interest is in traffic value, traffic. So traffic value and traffic are highly correlated. Makes sense. Traffic and referring domains is somewhat correlated. Traffic and Facebook shares is moderately correlated. And then nothing else. Okay, so at least within this set of metrics, you can see all the different counts. We're looking by these different topics. Like, for example, marketing trends and digital marketing co-occur a lot, right? There's a relationship there. But in this line here, the traffic line, answer is, guess what? Those topics, articles about those topics, at least with that in the headline, the frequency of that term doesn't matter. It doesn't have a relationship. The relationship really is on traffic value, which I would in this case actually say traffic value is a trailing, a lagging indicator. So that's not really useful. Referring domains is useful because it tells us that the number of referring domains to an article is related to traffic, and then Facebook shares for this industry, for this niche of marketing technology. Now, that's only 7,000 articles. These are the articles that have been written this year. If I want a piece of content to get traffic, sharing it on Facebook seems to be the way to go for this particular thing. Now, if I want to increase something else like referring domains, actually sharing on Facebook seems to matter there. Pinterest less so. Number of words, pretty weak. The next thing to do if we were going to be doing this for a client or a customer would be do the same word analysis, but instead of doing it on just the titles of the articles alone, getting the actual article text and doing the exact same analysis in the article text to see if the writing that is in the article itself it has importance, has relevance to the outcome. The other thing we can do is, you notice that we didn't really do anything with those URLs and domains. We can take this data frame and send it over to something like Watson Studio and run a much more complicated regression using categorical variables like the URL, the domain, etc., the author name, to see if those are specifics that we'd want to take a look at. Actually, you know what? Let's do that. That would be kind of entertaining. So let's take our clean data frame here and just write it out. Dump that out there. Let's go to Watson Studio. And let's go to Cplex test. Let's do an auto AI experiment. Just go call this SEO test. Create. Let's fish out our data file. And the column we care about, again, we're caring about traffic today. Regression type RMSE. Let's see, do we want to look at the settings? Nah, I think we're good. Let's go ahead and run the experiment. Now what Watson's going to do is it's going to take the massive amount of data, and it's not massive, it's like 7,000 rows, but it's going to try to take a look at each of the individual columns and say, is this column relevant to the result, not only by itself, but in combination. So one of the things that we did not do is when you look at this result set, we're looking at variables on a one-to-one basis. So is there a correlation between Facebook and traffic? There may be multiplicative effects. Like something that does well with Facebook and Pinterest together may do better than just Facebook or Pinterest individually. But you don't know that in this type of analysis. You have to use a more sophisticated platform that can get you those multiple combinations. It's called multiple regression subset analysis. And it's something that, for example, Watson would do really, really well because it has way more horsepower to throw at this sort of thing than my poor little laptop here. So it's now going through and taking a look at the different algorithms. In this case, it's using extreme gradient boosting, XGBoost regressors, and it's going to start building pipelines. And the pipelines it's going to look at is what has the lowest error rate. So it's already built pipeline 1, which is the default, just straight up, which I actually find is the most useful for doing variable importance. Pipeline 2 will do hyperparameter optimization, which is, how fast do you run the experiment. Let's go ahead and dig into pipeline 1 because I think there might be some good things in there. Let's go to feature importance, traffic value, of course, number of words. So this is interesting. In the gradient boosting regressor, it came out with number of words as being slightly more important. This is still not great. Right? This is again, like Pearson and Spearman correlations, the same general numbers apply. 0 to 0.25 is nothing there. 0.25 to 0.5 is moderate correlation. 0.5 and up is strong. In this case, traffic value, we already agreed it was a lagging indicator, so that's not super helpful. And then everything else kind of sucks. So even here, this tells me that we don't have enough data to draw a conclusion. We don't have any of the article text. We don't have any other things, but things like author and stuff didn't make it in here as being important to this pipeline, important to this model to try and understand this data set. So hope you had fun in watching this. This is how you do this kind of analysis for complex data sets, to see what's in there, to try and unpack them and make sense of them. You should do this with your marketing data, and these techniques apply to all marketing data, not just SEO, which is what we're playing with tonight, but things like marketing automation, lead scoring especially, super important for it. Thanks for watching. Hope you had fun. Hope you enjoy the rest of your evening. Take care.
Want help solving your company's data, analytics, and digital marketing problems? Visit trustinsights.ai today and let us know how we can help you.